Look up at the night sky. What do you see? A vast expanse of darkness, dotted with countless points of light. Each one of those points is a star, burning brightly in the cold vacuum of space. But have you ever wondered about the stories these stars might tell? Twinkling stars scattered across the darkness, they seem so distant, so isolated, yet they are part of a grander tapestry. Each twinkle is a beacon, a signal from a distant world, a reminder of the vastness of our universe. You might be surprised to learn that many of those stars are not alone. In fact, they often have companions. These companions are not just nearby, they are gravitationally bound, locked in an eternal embrace. They have a partner, another star locked with them in a cosmic dance. This dance is a delicate balance of gravitational forces, a celestial waltz that can last for billions of years. We call these systems binary star systems. They are fascinating to study because they offer a unique glimpse into the dynamics of stellar interactions. Binary stars can vary greatly in their characteristics, from their size and brightness to their distance from each other, and they are incredibly common. In fact, binary star systems are not the exception but the rule. They are a fundamental aspect of our galaxy's structure. In fact, astronomers believe that more than half of the stars in our galaxy are part of a binary system. This means that when you look up at the night sky, you are likely seeing many stars that are part of these fascinating systems. These systems are not just beautiful to look at, they are also incredibly important for our understanding of the universe. The interactions between binary stars can tell us a lot about the fundamental forces that govern the cosmos. They also offer scientists incredible opportunities to study the universe around us. By observing binary star systems, astronomers can learn about the life cycles of stars, the nature of gravity, and even the potential for planets to form and sustain life. By observing how these stars interact, we can learn about gravity, stellar evolution, and even the potential for life beyond Earth. The gravitational pull between the stars can affect the formation of planets, and studying these systems can provide clues about the conditions necessary for life. So next time you gaze at the stars, remember that many of them are not alone. They are part of a complex and beautiful dance, a dance that has been going on for billions of years and will continue long after we are gone. They are part of a celestial partnership waltzing across the cosmos. This partnership is a testament to the beauty and complexity of the universe, a reminder that even in the vastness of space, there is connection and harmony. So, what exactly is a binary star system? Simply put, it's a system where two stars are gravitationally bound to each other. These stars orbit a common center of mass, creating a dynamic and fascinating celestial phenomenon. Imagine two celestial dancers whirling and twirling around a common center of mass. Their movements are dictated by the invisible force of gravity, pulling them together in an eternal dance. That's the essence of a binary system. These systems are not just rare occurrences, they are quite common in our universe. These systems can vary greatly in size and distance. Some binary stars are similar in size and brightness, while others can be vastly different, with one star being much larger or brighter than its companion. Some binary pairs are so close that they almost touch, their outer layers interacting in a fiery embrace. This close proximity can lead to fascinating interactions, such as mass transfer from one star to the other. Others are separated by vast distances, their connection visible only through the subtle tug of gravity. These distant pairs may take hundreds or even thousands of years to complete a single orbit around each other. But regardless of their differences, all binary stars share one thing in common: they are locked in a celestial dance, their fates intertwined for billions of years. This dance of gravity and light is a testament to the beauty and complexity of our universe, reminding us of the intricate connections that bind the cosmos together. Now you might be imagining these stars moving in perfect circles, like a pair of waltzing figures. But the reality is much more complex. The gravitational dance of binary stars is often a chaotic and intricate ballet. The stars don't orbit each other in perfect circles. Instead, they move in elliptical paths, sometimes coming close, sometimes swinging far apart. The more massive star, like a powerful dancer leading the way, dictates the flow of the dance. The less massive star follows, its movements influenced by its partner's gravitational pull. This intricate dance is what makes studying binary systems so fascinating. When we think about planets in binary star systems, we often picture Tatooine from Star Wars with its iconic double sunset. This image has captured the imagination of many, but it's not just science fiction. In reality, there are planets that experience this phenomenon. This image reflects a real type of planetary orbit called a circumbinary orbit. In such an orbit, a planet revolves around two stars, which are gravitationally bound to each other. These stars act as a single gravitational center for the planet. Here, the planet circles both stars, treating them as a single gravitational center. This creates a unique dynamic where the planet experiences the gravitational pull from both stars simultaneously, leading to complex orbital patterns. But there's another way planets can exist in these systems: the S-type orbit. In this configuration, the planet orbits only one of the stars in the binary pair. In this scenario, a planet orbits only one star in the pair, while the other star remains further away, casting its light from a distance. This means the planet is primarily influenced by the gravitational pull of the closer star, while the second star's influence is much weaker. Each type of orbit presents unique challenges and opportunities for any potential life on these planets, shaping their environments in fascinating ways. For instance, circumbinary planets might experience extreme variations in temperature and light, depending on the positions of the two stars. On the other hand, S-type planets might have more stable climates but could still be affected by the distant star's gravitational influence. Understanding these orbits helps scientists learn more about the potential for life in binary star systems and the diverse conditions that might exist on these distant worlds. Astronomers have already discovered several planets residing in binary star systems. One fascinating example is Kepler 16b, a gas giant planet about the size of Saturn. This planet circles both stars in its system, much like Tatooine in Star Wars. Another remarkable system is Kepler 47, home to not one but three planets orbiting a pair of stars. These discoveries tell us that planets can indeed form and survive in the complex gravitational environments of binary systems. As we continue to explore the cosmos, we're likely to find even more exotic worlds orbiting double suns, each one a testament to the diversity of planetary systems in our universe. The search for life beyond Earth often focuses on the habitable zone, the region around a star where temperatures are just right for liquid water to exist on a planet's surface. But how do you define this zone when you have two stars? It gets complicated. The habitable zone in a binary system is not a simple ring like it is around a single star. Instead, it's a dynamic shifting region, influenced by the combined light and heat from both stars. The size and shape of this zone depend on the stars' masses, their distance from each other, and even the eccentricities of their orbits. While the idea of a planet with two suns sounds romantic, the reality is that life on such a world would face significant challenges. The increased radiation from two stars could be detrimental to life as we know it. Imagine sunburns on steroids. Additionally, the gravitational tug-of-war between the stars could make planetary orbits unstable, potentially flinging planets out of the system entirely. And let's not forget the extreme temperature swings a planet might experience as it journeys through its unusual year, alternating between the heat of two suns and the relative coolness of a single star. So why go through all the trouble of studying these complex systems? Because they hold the key to unlocking some of the biggest mysteries in astronomy. By observing binary stars, we can precisely measure their masses, providing crucial data for understanding stellar evolution. These systems also offer unique insights into the processes of star formation. How do two stars end up gravitationally bound? What role do binary companions play in the birth and death of stars? These are just some of the questions that studying binary systems can help us answer. As we continue to develop more powerful telescopes and refine our observational techniques, our understanding of binary star systems will only deepen. We can expect to discover even more exotic planets orbiting double suns, some perhaps even harboring the potential for life. The study of binary systems is not just about understanding these fascinating objects themselves, it's about using them as cosmic laboratories to test our theories of gravity, stellar evolution, and planet formation. By studying these celestial partnerships, we gain a richer, more complete understanding of the universe we live in and our place within it.